Okay, so let's look at some more complicated problems using root method. You're going to notice that we use root method when there is only one term with an x in it. So all the examples you saw yesterday and the ones that I'm going to show you today are going to be ones that have only one term with x in it. So this looks like one that we saw yesterday. The only thing that's going to be different is the last step we're going to need to do to solve it. So we want to get rid of subtraction first by adding 8 to both sides. That gives me 4x squared equals 20. I'm going to divide both sides by 4 to get rid of the division. And that's going to give me x squared equals 5. And then to undo squaring, we take the square root. We know anytime we use the square root symbol, we have to put plus or minus. Now the only thing that's different about this is 5 is not a perfect square. So I'm going to have to use my calculator to take the square root of 5. And the square root of 5, if we round to the nearest hundredth, is 2.24. So for some of the ones we're going to see moving forward, it's going to be a non-perfect square that we're going to have to use a calculator for. All right. So this one looks different because it is still one we're going to use root method for because I have only one term that has an x, but it looks more like it's in kind of vertex form right now. So what we're going to do is we're going to still do reverse order of operations. So we're going to work from furthest away from x to closest to x. So the thing that's furthest away from x right now is the 2 that's multiplying the parentheses. So since it's multiplication, to get rid of it, we're going to divide. So we're starting off by dividing by 2, which gives us x minus 4 squared, because dividing by 2 gets rid of the 2. And 32 divided by 2 is 16. Now, the thing that's closest to x is the minus 4. The next furthest thing is the squared, so we actually have to get rid of the squared next. So we're going to take the square root of both sides. The square root of x squared gets rid of the squared, and we're just going to be left with the x minus 4 inside of the squared. Anytime we take the square root, we have to put the plus or minus symbol. So the square root of 16 is plus or minus 4. Now this is going to be kind of like absolute value equations because we really have two possibilities. We have that x minus 4 could be positive 4, and we have that x minus 4 could be negative 4. And so we're going to add 4 to both sides, and that's going to give us x equals 8 as one answer. And if we add 4 to both sides of this equation, we're going to get x equals 0. All right, so one more like that one. We're working from furthest away from x to closest to x. Some people's first instinct might be to combine 5 and negative 2, which we are not going to do because the negative 2 is multiplying the squared, the x plus 1 squared. 5 is being added to that. So we actually want to get rid of just the 5 first. So to get rid of positive 5, we subtract 5 from both sides. That gets rid of that there, and we're left with negative 2 times x plus 1 squared equaling negative 4. Now we have to get rid of the multiplication of the negative 2 because that's next furthest away from x. And we get x plus 1 squared equals positive 2. Now we have to get rid of the square root, or the squared by taking the square root. That gives us x plus 1. 2 is not a perfect square, so I have to take the square root of 2 using my calculator. That's going to give me plus or minus 1.41. Anytime we take the square root, we got to put that plus or minus symbol there. And so that forces me to then make two equations. And then I'm going to subtract 1 x is 0.41. And I'm going to subtract 1 here. X is negative 2.41. So those are my two answers. So we cannot use root method for this problem. Why can we not use root method for this problem? The reason is because these two numbers both have x in it. Both terms have an x in it. Root method is only when there's one term with x. And so what we're going to talk about next, not in this video, is how can we rewrite this part of the equation to have only one term with x. And the way we're going to do that is we're going to notice that this is actually equivalent to x plus 3 squared. Once we write it like that, we're then going to be able to use root method from there by taking the square root of both sides, not forgetting our plus or minus, and making our two equations. So we're going to talk more about this afterwards, but I just wanted to point out why at first we couldn't use root method. That was because x was in two different terms. And then kind of just highlighting what we will do. We'll try to take something that has x in two terms and break it down to something that has x in only one term, and then use root method from there.